Hello and welcome to the Cycling Performance Club podcast, a weekly podcast where a panel of scientists, pro cyclists and cutting-edge coaches discuss topics in training, performance, science and all things cycling. The show is co-hosted by Dr. Jason Boynton, sports scientist and cycling coach, Damien Roos, who's the founder of the Semi-Pro Cycling podcast and a professional cycling coach, and me, Cyrus Monk. The Cycling Performance Club podcast is recorded live in the presence of an online audience on the Clubhouse app. You can join in and ask questions or participate in any of the discussions as we are having them. So this week we are looking at nasal breathing, and Damien has been having a close look at the research and the hype surrounding this, and we will be discussing this research and how legitimate these claims around nasal breathing might be. So Damien, do you want to take us away and outline the topic for this week?
Sure thing. So this is one of those things that I mentioned a while ago in the coaching to-do list because it seems to have slowly been coming at me from different angles. So it's one of those things I wanted to just have a really good look at. And to narrow this down, for me, it came down to, does nasal breathing really improve performance? And I wanted to try and understand specifically, how does the way that we breathe during exercise affect our performance?
I'm butting in here after we recorded the show to say that this show started out about the main topic, nasal breathing. But as you'll hear, we quickly shift off topic and into a discussion on evaluating new interventions. And there's a lot of value in what we discuss. For me, that value is moving research away from the idea that research is just finding sources of information that confirm your pre-made decision on a product or intervention, and really letting the information guide the process, which, by the way, is one of the reasons I like doing this show with Jason and Cyrus. They might not have the same ideas and come at interventions with a desire to let the information uncovered do the talking. Anyway, I just wanted to give you a heads up that that's what's coming, but let's get back to the topic.
Breathing is this thing probably people don't think about too much. I put a little bit of time into thinking about breathing here and there, but overall, it's this thing when you're mid-workout, you're trying to get as much air in as possible. You're just probably thinking about riding your bike and moving forward and just doing it. It's not something that consciously you would shift up in the middle of a hard effort or whatever to go from your mouth to your nose. So I wanted to look at this thing of, will modifying your breathing give you a performance advantage? All these sources seemed to come from one place. So this information seems that it's coming from one place. And I'm not going to really talk directly to that original information source. I just want to talk about the ideas that it's generating, because I don't really want to get stuck on this idea of trying to disprove someone or go after anybody.
We'll save that for another episode.
Maybe. Yeah, it would be. There's a lot
separate
to it,
issue. Yeah.
And I was just trying to focus it down into one sort of area, but there is actually a lot of different parts of this, because breathing is more than just, say, choosing nasal breathing for one part of your recovery. And we've spoken about this, Jason. There is a lot of different elements here. Different sports have different conditions, different types of breathing for different situations. So this is where we're starting, and we'll kind of see where we end up, I guess. So the main technique here is, it is nasal breathing through your nose. And I wanted to take a bit of a deep dive. And the first place that I started was trying to understand how we normally breathe during exercise, to see if there was any papers around that. And as expected, just like people have individual differences in performance itself, there are a wide variability between how people breathe. And this is during rest and during exercise. And it's a pretty safe conclusion that most people either breathe through their mouth or through their nose during rest or exercise. Just to cover that off, it's mixed up. And I kind of went digging into like the medical world a little bit in this side of things, because there were some crazy stats that I was reading regarding how many people actually have some type of issue with their nasal passage. And it's basically like 94% of people have some issue where there's something going on in the makeup of that whole area that means that they aren't breathing optimally.
Cyrus, you know anything about that?
Yeah, I was going to say I'm happy in the 94%. I was just thinking from this podcast that we were going to be saying 33% because it's just 1 in 3 that is the mouth breather. But no, I would, I'm surprised it is that high. But for me personally, it's good to hear.
I think it would be everything from something just like your septum is just not straight or something. You know, it's just not the plumbing is perfect on people. So, and then that spectrum would be, to the point where some people can't even breathe through their nose and they get into a lot of trouble like that. But that's kind of like the medical side of just making sure that everything works.
If it's that prevalent, it kind of makes you question how strong is the selective pressure of having a good nasal breathing passage, right? In terms of an evolutionary sense.
That's my thinking. If you see the incidence that high, then it's clearly not going to be something that's going to be a major issue for the majority of people.
Mm-hmm. Unless everybody is just underperforming.
That too. That's it.
Fair assessment.
Like in sleep, if they're not sleeping properly, like there's things thrown around. Like if you wake up and you have a dry mouth, then during the night you haven't been using your nose, so then you're not optimizing things. A lot of these types of claims around, but let's kind of stay focused here. And but I do want to talk about something that kind of surprised me, and it's just this idea that nose breathing actually opens the diaphragm up more than mouth breathing. And this got me thinking about something that I learned a long time ago, and I don't know where I got it from. But this idea, if you would make an attack like a 10-second effort or some other type of effort, if you want to recover quickly, I've always had this thing in my head that I would take breaths in through my nose to try and recover better. I don't know if this is something either of you have heard about before.
No, I haven't heard about it. The thing that I've heard the most about it is always just if someone is going well or doing it easy in a race that they're nose breathing. But I think that's more just referred to as the fact that they're doing it that easy that they're able to breathe through their nose. So, but maybe that phrase stemmed from similar things in terms of in a recovery phase. If people have been told to nose breathe, then in a race, if you're doing it, it's just implied that you're recovering. So you're nose breathing and finding it quite easy.
Yeah, but that would also imply that you're doing it over a longer period of time. For me, it's kind of like you say you're trying to latch onto the back of a breakaway and you get there and then you take a couple of deep breaths in through your nose and then you're just back to mouth breathing because you're still struggling. It's just... potentially this thing of changing the way that your diaphragm reacts to the breath. And I didn't investigate this. It's just something that came up and on a bit of a side, and it was interesting because it lined up with this idea I have. But anyway, let's move on. Getting behind the supposed benefits of nasal breathing. It sort of starts with the arguments against mouth breathing, the nose breathers and the mouth breathers. Mm-hmm. And the main one seems to be that mouth breathing leads to over-breathing, which is defined by more air going into the body than the body requires. And then this leads to too much CO2 being removed from the body and the bloodstream. This is something new to me. I have never heard this before, over-breathing. There's hyperventilating, but over-breathing, it seems to be, again, it's this thing of where it's a continuous thing that you potentially are doing all of the time when you're doing any type of exercises versus just hyperventilating because of some specific incident or event that happens. So the flip side of this is that one of the supposed benefits of nose breathing is it reduces your exhalation of carbon dioxide and increases oxygen uptake by the tissues. So this is the claim. It comes down to basically this is kind of the claim around this. There's other ideas that nasal breathing filters, warms, and humidifies the air that you breathe. So that's kind of separate, and I'll touch on that briefly, but I wanted to start with this idea of reduced exhalation of carbon dioxide and increased oxygen uptake by the tissues. So have a bit more of a deep dive into this, and I do want to note that this info is new to me, and it comes from the people that are pushing this idea. So don't shoot the messenger. And I'm going to try my best to get through this. As I mentioned, it's all sort of stems from this over breathing idea. And it seems to be, this is the main reason why you want to choose your nose instead in training and racing. And this is because the body is apparently getting in more air than the body requires. So it's based on this phenomenon. So someone went back and based on this phenomenon called the Bohr effect. An interesting thing about this is that it's a Danish physiologist from a long, long time ago that sort of went through this. There's a bit of a challenge against who actually created it, but his name was the one that stuck. And so if we step through it and just step through the normal process, oxygen is normally carried by blood in hemoglobin, yes. Carbon dioxide and heat are produced by active tissues which are using oxygen to create energy. When the blood reaches these muscles, the carbon dioxide and the increase in temperature cause the hemoglobin to change shape and release the oxygen that it's carrying. Carbon dioxide also increases cardiac output and causes dilation of blood vessels, improving blood flow. So when you relate this to exercising, these things all start happening as a reflex response. And when we exercise, we make more fuel in the muscles. So we produce more carbon dioxide in the muscles. And this carbon dioxide dilation of blood vessels supplying the muscles. And so we get more oxygen arriving and the hemoglobin releases more oxygen when it gets there. Does that make sense?
Yeah. It sounds like they're talking about the hemoglobin dissociation curve. And I think we discussed that in a previous episode. I just can't remember which one it was, but it was relatively recent. So yeah, that all kind of sounds familiar.
We'll put an explainer of that in the show notes as well, because it is pretty relevant to this whole topic, and there'll be someone, we'll find a credible video of someone that can explain it a bit better, because if you have a visual for that curve, then it makes it a lot easier to understand it as well.
Mm-hmm. Yeah, it basically conditions where you would want more oxygen, those conditions affect the affinity of hemoglobin, which is a pretty nice thing to happen. But it doesn't necessarily mean that good things are happening. One of those things that affects hemoglobin's dissociation curve, what shifts it is, a decrease in pH or an increase in acidity or an increase in temperature. These are things that are going to change that affinity. So if the temperature is going up or if the pH is going down, then yeah, you want more oxygen to be released to the working muscle, because, I mean, if there's an increase in acidity, there's probably means that there's something going on that you want to help increase the aerobic ability of the exercise, if that makes sense, right? So just because it's shifting that curve doesn't mean it's necessarily a great thing. So acutely, if that makes sense.
So yeah, so potentially even just the idea of, well, the idea here is can we enhance this effect that's happening through breathing nasally, but potentially even the idea of if this even is important is probably a bigger question to answer.
Mm-hmm. Yeah, it's a very, very big question. And I think when I was doing a little bit of literature search around this, and one of the things to kind of note is a lot of the literature that is cited isn't necessarily nasal breathing literature. A lot of the stuff that's cited with exercise and performance improvements through manipulation of breathing has to do with breath holding or reduction of breathing rates. And if you start thinking about it, those aren't the same thing. So a reduction, even though they're similar, I would be very careful about taking the results of a breathing rate reduction study and then moving it over to a nasal breathing conclusion. Because,
like, in other words, on the surface, if the idea of that, if you're breathing through your nose, you are trying to reduce the volume of air that you're breathing per minute. But if you're trying to start comparing that to controlling, say, 4 breaths every 10 seconds or whatever breathing pattern it is, fundamentally that those two processes may be different. So then it's you can't compare the two.
They're similar in some aspects and different in others. And I guess what I'm saying is I would be careful about applying certainty in the findings of one and then applying it to the other, if that makes sense. So they could be interchangeable and under certain circumstances. I would just be skeptical of how interchangeable they are. And yeah, I think another paper that came up was another example was they were looking at training with swimmers, and they were looking at their breath holds and with the swimmers, and one group got to hold their breath or breathe 4 times, and the other group per length, and the other group got to train breathing 7 times per length. And then they took these swimmers and tested their run economy. And the 4 breath group, I think, increased their running economy more than the control, or the 7 breath group. But even that situation, I would be concerned because it's breathing during swimming, and swimming is done horizontally and has the hydrostatic pressure of the water on the body, has the different temperature stress on the body, which could be also changing cardiovascular responses. It also has the dive response, and there's a whole slew of things that you get during swimming and changing your breathing during swimming that you wouldn't necessarily get if you were going to change your breathing during cycling, and in terms of like what you would get as a training effect. So if I was going to really want to see what I would need to really convince me is a training study set up with cyclists, well-trained cyclists, properly powered, and showing a performance improvement. And I don't know if you saw this or not, but it seemed like most of the studies where they saw improvements, it wasn't cycling studies, it wasn't necessarily well-trained people. A lot of the improvements weren't performance improvements. They were more physiological improvements like hematocrits and things like that, which you have to get into the conversation of, is that change in hematocrit or this other physiological response actually physiologically meaningful in the sense that it will increase performance? So yeah, I can see where there's a lot of how someone who would, especially if you are marketing some type of training or intervention system to improve performance for athletes, I could see how you'd be really incentivized to kind of glaze over those things and kind of merge these studies into one to kind of show them as proof that this type of thing works. But for me, as a coach, skeptic, sports scientist, I'm kind of sitting back and going, from what I saw in my little search, I haven't seen anything yet that really convinces me. And the other thing to mention in there is that there's seems to be a lot of extrapolation from single acute exercise bouts, physiological findings within acute exercise bouts, and then extrapolating that into a training response and a benefit down the road. And that to me is problematic. also, because that happened with my research in terms of I was thinking, oh, cool, intervals is going to be better. That has a higher time at or near VO2 max. It's going to have higher shear stress during the high intensity exercise portion of the session, yada, yada, yada. Get the results after the training study. That's not what it said. So you have to be really careful when you're reasoning what you think is going to happen if you train multiple times and then try to extrapolate out what you see acutely into a training result. Hopefully that makes sense there.
It does make sense. It's half the coach's job to kind of do this, but I can see how you can get into trouble if then you're just trying to then push this to a wider audience. But let's talk about two of the studies that I dug up. I think they get around the issues that you were talking about. There's one study. They have 9 individuals performing one Wingate test. So Wingate is just a 30-second all-out test. And they did it under nasal or oral breathing. And they showed that nasal breathing did reduce hyperventilation. However, there was a compensatory increase in heart rate under these conditions, implying increased cardiovascular stress. And there was no difference, so the performance part, no difference in power output or performance measures between the two. So that ticks boxes, doesn't it? Like that, okay, it's one test. It's like, I think they said they were kind of trained. The VO2 maxes seem to be around 60 or so. But one 30-second test and then you're making an assumption on that seems a bit...
Yeah, like no cyclists train like that, except for maybe track riders. And even the track riders will be primed before they do their sprint because they've been riding around a little bit. Like a Wingate is from a standing start. And well, there's a little bit of a warm up and then they for maybe 10 seconds and then they drop the mass and then you go for 30 seconds. So there's a lot of times there's not like as much of a warm up into it. And then you really have to kind of question like how much of the aerobic system is primed.
How much are you breathing at that point? A 30-second effort, you're not sucking in air to get through it necessarily.
No, I mean most of the heavy breathing is going to happen after the effort, especially if you're just looking at one.
Basically, what I'm looking at here is if I was going to design a study to assess this, I would not be using a Wingate test. It's really strange to me that they've chosen to use a Wingate test to assess.
A measure of anaerobic performance.
Yeah, exactly. It's the most well-known measure of anaerobic performance, and they've used that to test the validity of nasal breathing, which is going to be something that predominantly affects aerobic output. So that's a really strange study design, even if the rest of it holds up. Just the choice of the test is a peculiar one.
I don't think it's strange if you consider that you can basically do that in any sports science lab anywhere which allows basically any undergrad to conduct a sports science study to publish at a conference or something like that. Yeah. As soon as you're like, this is easy, cheap, easy. Most labs are going to have a Monarch bike. Learning how to conduct a Wingate is baseline things you would learn in a sports science course. Holding your breath is going to be a really easy thing to do. And collecting power and all that type of thing is going to be easy enough to do if you have the right device. And
one session without any pre-testing for the athletes as well. So,
yep.
Although they did assess their VO2 max, which would take longer than the actual test itself.
Yeah.
All right, let's move on to the next study.
Yep.
And it was a running one, and they were trained runners because they were practicing nasal breathing in training and racing for at least 6 months prior to being tested. And the test was, what do they say here? It's like a trial a high-level steady-state trial at 85% of their maximal GXT running velocity. I got no idea what that is, but let's just hope that it's...
That's basically their equivalent of their running FTP. Like, that's what we talked about, the 82.5% of the graded exercise test, like the maximal aerobic power, which you've gained from a step test or a ramp test. That would be the running equivalent when I hear that graded exercise test, and they've done a ramp or step and then assessed 85% of that is something they can maintain for a long time.
All right, that's a good test. Then I imagine then at least maybe 30 minutes or something of effort as well. The results showed no loss in VO2 max between nasal and oral breathing, with an improved physiological economy in nasal breathing. That's about as good as it got for me, digging around.
Yeah, and I looked at it. You have to be careful about this study. It just because it's kind of weird in the sense that it wasn't a training study, even though they were using people that were trained in this way. That was kind of one of the things that kind of stuck out to me would have been a better study design or more interesting to me. And maybe there's another study out there that we didn't come across that did this, but to have the individuals that weren't nasal breathing, or before these people decided to take on nasal breathing, and train them and see how they changed after a nasal breathing during exercise intervention.
Mm-hmm.
And that would be a lot more convincing. But this is basically they had the intervention and then they did acute testing and then looked at the differences between doing exercise with nose breathing versus doing exercise with oral breathing, and then tried to extrapolate testing conclusions from that. And I'll just read the conclusions off here. So this study supports the ability of recreational runners to utilize a nasally restricted breathing pattern at all levels of running intensity without loss of VO2 max and with superior economy following an extended training period using this practice. So
what practice?
Yeah,
it's not clear exactly what they did.
Yeah, because without doing testing before the intervention, how do you know what changed? And how do you know? And they didn't have a control group. They just had this group. So it's just set up really weird, right? So they didn't do it a proper intervention where they looked at people who weren't doing nose breathing and then looking at the results afterwards to see what changed in terms of all of these ventilatory measures and performance. And then they also didn't have a control group to compare this acutely. All they had was basically an experimental group that they tested under nose breathing and mouth breathing conditions. And without getting deep into the study, that, I don't know, I mean, it's not like they didn't find anything, but there's a few other steps I feel like they should have looked at. And they seem like they over extrapolate their findings a little bit more, but I think I'd have to read it more closely before I really came down to that.
So both these studies for me kind of represent where the science or the published papers are at around this topic are chosen because they seem to have the right population. At least one of them had cycling of some sort, even though it's questionable the level that the people were, which for me is a bit of a red flag as is. I don't know how convinced you guys are at this point that it's something that you would consider in training.
My level of convincedness would be 0 at this point.
Yeah. Well, it gets into this idea of when do you apply an intervention or a supplement or something like that. And in this case, or all these cases, it gets down to an epistemological conversation. And the case here would be the burden of truth is on the person making the claim. And there might not be a specific person that's making the claim here, but it's on the promoter of the intervention to come up with the evidence to do it. And without proper evidence to make their case, then you would not implement it, because otherwise you would be implementing just about every intervention that would be out there, the ones that would work, the ones that didn't work, the ones that could hurt you. And so in this scenario, you carry on with what your normal training is until you see enough evidence to where it would, once you do the cost benefit analysis on the intervention, then you would hopefully see enough of the results. And in order to convince at least me, I would imagine you guys as well, like you're going to want to see a really well-designed study in the specific scenarios that you want to see, and before you have an athlete potentially chasing their tail down this road. Like I want to see a really good training study with 30 trained cyclists doing this intervention, and then real proper tests done at the end, like how did their peak power output change? How did their time trial power change? And then a number of the physiological measures that would hopefully back up and explain the mechanisms for whether there was a change or not. And in lieu of that, I'm not going to be running after this intervention, I don't think, because the cost is probably too high to implement it based on the evidence that we're discussing today.
I got a random question regarding when you see someone trying to present something and you feel like things are being cherry picked because the papers they're picking, for example, may be 20 or 30 years old, but it's not. But it never made it past the point of a few researchers looking into it. Mm-hmm. It never moved into the performance world and more, people using it and making an impact and stuff. Is that for you, Jason, is that a red flag? Like, do you see, like, good science doesn't age, but definitely there's a reason why some things just stop.
Yeah.
Is it a red flag for you when you start seeing these older studies that, and you've never heard of them and out of nowhere? And
yeah, I don't want to say the term red flag. And one part of my brain, the cynic side might be like, yeah, that's a red flag. But then if I put the sports scientist hat on here, they could be onto something. You always have to say they could be onto something. But yeah, in our world as a coach, our time is finite. We have to figure out, does it work? Because we've got a ton of other things going on. And so this is one of those things that I would be like, okay, why isn't this taking off with well-grounded pulmonary physiologists? I think I brought up Jerome Dempsey's name within this conversation when we were first starting to talk about it. And I think about him, and would he be promoting this? Or I think of other sports scientists out there that are well-versed in hypoxia training and that type of thing. And it's like, well, how much are they pushing this? Because at the end of the day, the sports scientists out there that are working with high-level elite teams are very incentivized to find quick and easy interventions that have massive amounts of performance improvements, right? And one side, they have to be very careful about what they implement with an athlete because, again, there's a cost to the athlete. And so they are going to be, hopefully, more reserved in what they do, hopefully. And I mean, this kind of gets into a conversation. I saw a sports scientist, a well-respected sports scientist that works with elite teams, and he was talking about the keto diet. And he was saying, yeah, if all I had to do was reduce carbohydrate intake for my athletes and I was guaranteed to see a performance improvement, yeah, I would do it. But there wasn't enough good evidence for him to implement that type of nutrition intervention. And I think it could be said for the same thing here. It's not to say that it doesn't work, but it's just curious to me that it never got picked up and moved forward by anybody really. But you could see, this is not to say that interventions that don't work haven't been pushed by people in the sports science realm, though. And you could definitely see if you got a strong, charismatic figure pushing this type of intervention, and they were incentivized by a product or service that they were selling to kind of, I don't know, glaze over the discrepancies that I was talking about earlier with these studies, then yeah, you could see how he's might show up like the Pied Piper with his magic intervention and say, hey, we've got this system that is going to improve in performance. And then they can gish gallop you with a bunch of studies that look good on the surface. And then you're buying their service. And really, it could be the case that as soon as you get one major institution that bought into the service, then it's like, well, what are they doing? We should do that too. So it's a very careful thing. And a lot of the times it always comes back to, what am I doing right now? And is this intervention going to be better than what I'm doing right now? Because one of the things I kept thinking about when I was reading through these interventions, I was like, well, especially with the runner one, I didn't get a chance to look into the methods deeper, but I was like, I wonder how many interval sessions they were doing, because I wonder if you would just be able to get the same kind of response by doing high intensity interval training. And it kind of makes me wonder if they were just doing a lot of steady state and quote unquote base training. Well, if they were potentially getting a stimulus from something like breath holding, but weren't doing any kind of hit, okay, well, maybe the hit would be better, if that makes sense. So I get, like I said, I can't really speak to it. It's more about, for the listeners, it's more about having that thought exercise and kind of getting back into the research and digging a little bit deeper before buying into these things. It's always a good idea. I mean, even if you hear it here and we're like, this looks good, it's always a good idea to check our references and make sure that it measures up to your standard. Yeah, those are my thoughts.
I just wanted to take a quick break here to say thanks for stopping by and listening to the show, and to give you a quick reminder about who we are and where you can find us. The show is a collaborative project between sports scientist and cycling coach Dr. Jason Boynton, professional cyclist and cycling coach Cyrus Monk, and myself, Damien Roos, professional cycling coach and author of the Cycling Science Digest. If you want to get in touch with any of us or find out more about what we do, check out the show notes of this episode for links to each of our websites or social media accounts. Also, a reminder that you can be part of the show too. We host the show live on Clubhouse every week. Just search Clubhouse for the Cycling Performance Club and you'll see our scheduled room. And with that, let's get back into it.
I got a question for you, Cyrus.
Yep.
Something like this is one of those things that you can potentially add on top of what you're already doing. So it's not necessarily where it would be such an intervention that it would drastically change the makeup of your training and things. You know, like if you were doing an easy ride and you just wanted to nose breathe through that ride. Is that something you would consider? Like when you say that you're not convinced, is it something that you would consider trying out just to see what happens? Or it's like, it's a hard no until I'm convinced it's a yes?
Yeah, well, it does seem to fall in the basket of can't hurt, might help, in that it's not going to be damaging or unsafe. Where it might hurt, not in a safety regard, but it might be detrimental, is if I'm doing high intensity intervals that I can't get enough air in through my nose, that would end up in a decrease in power for those intervals and decrease in training benefit. So I definitely wouldn't consider it in that regard. But yeah, for the easy rides, it's not going to change at all my power output or anything in that regard. So I still think it's just something where I would want to see more evidence even than what's out now. There's some interventions that there's limited evidence, perhaps a bit more than what we've been able to uncover for this one, where I would think, well, if it's free and not going to cost me any time, then I'll implement it just in case it does work. But with this one, like with the limited amount of stuff out there, even though it's not costing me anything or costing me any time, I still can't see myself going out on my recovery ride today and breathing through my nose instead of through my mouth.
Yeah, and for me, I think the baseline here is there a way to measure if it's actually making an impact? And I think part of the strength of the argument that is being put forward is there's a couple of simple tests that you can do to test things out, so you can see some type of progression. I am actually skeptical on whether that progression is anything worthwhile for performance, but it is this thing. If you could measure it, maybe that would help you see within yourself whether it's working or not. But at this point, if you were to do something like this, it's like that famous advertising quote. I know 50% of my advertising is working. I just don't know which 50%. So, yeah. Yeah, exactly. It's just kind of throwing it in the mix. And I kind of sit on that realm of like, if there's nothing that I could see actually making, like I couldn't measure the difference anyway, then I'd just be like, what's the point? Just reduce the mental stress or whatever.
Yeah. And it's something that's very prevalent just in science in general, that any hypothesis has to be testable. And if you're assuming this, and if I'm implementing it amongst all my other training, then I'm not going to have any way of actually measuring whether there's a benefit from it. And this is why I think things like this can get some traction just anecdotally within performance realms, because if Tadej Pogačar, for example, just started nose breathing 2 months before the Tour de France, and then tells his friend, I was nose breathing then. His friend goes and tells everyone, this is what Tadej Pogačar's doing, and he won the Tour de France. All like the inference from all these people thinking, that must be the secret, not all of the other things that he's doing, all of the other interventions with really high impacts. I think this is how these kind of things can get traction quite quickly. And I do hear a lot of stories, not on this topic specifically, but many others that, just these little things that I sort of have to think to myself, even if there is any effect size, it must be so tiny compared to the rest of the training and the rest of the interventions that they're doing, yet that's the one thing that people will grab hold of and think is the secret to their success.
Yeah, and that's just the other side of what Jason was talking about. He's talking about like the sports scientists grabbing onto it. You're talking about the people in the cycling world grabbing onto it.
Yeah.
So just how it gets traction. Yeah.
Maybe it's my own bias as well, but I feel like the triathlon world is really notorious for this. Like, he won Ironman and all he did was train indoors for 6 months or whatever that story was, or he was on the keto diet and didn't consume any carbs and he won Kona, and you get that a lot, I feel like, in triathlon, but I don't know if I'm sure it's prevalent in cycling as it is probably in most endurance sports, but I don't know if we're as bad as you could get with the triathlon scene.
I would be interested in testing that out. Like if we did an episode where we all brought in some ideas that we have that we just came to us through just natural progression of getting information from peers and people we ride with and stuff. Mm-hmm. It would be interesting to kind of dig a bit deeper into that, I think.
Mm-hmm. One bit of physiology that I forgot to mention was I was looking a little bit into the claims around improving aerobic performance after breath holds and breath control type interventions. And this is actually a pretty common thing. among divers. But I think this is another thing where what divers are doing, and divers increasing their ability to exercise while doing a breath hold, isn't necessarily the same as what is going on during the end of a bike race where you can breathe freely. And if you look at these indigenous populations that have been diving for like thousands of years, they have enlarged spleens. So what they get is a splenic adaptation, and you can actually have interventions to get splenic adaptations. And what basically happens there is that the spleen kind of, gorges itself on red blood cells. It's able to hold on to red blood cells that are oxygenated. And as you continue your dive or hold your breath, then the spleen will release those red blood cells into the system, and those red blood cells will transfer oxygen to where it's needed. And again, to me, I'm very skeptical that that would have any benefits within cycling. And you might say, well, couldn't you just have extra red blood cells stored up in your spleen, and then at the end of the race, when you really need it, you could just release it? And yeah, I'm not sure the physiology works like that. Someone's got a paper, be happy to look at it, but it's one of those things that there's getting back to one of the original claims around there's too much oxygen or too much air around, or too much ventilation during mouth breathing. And let's see, I can see an argument for reducing mouth breathing while you're sedentary. I can see that. I would entertain that probably a little bit more than this one that's around nose breathing during exercise. But one of the things to know about, this idea of there's too much breathing, too much air coming into the body when you're mouth breathing. Well, the lungs are overbuilt. They're massively overbuilt. And this gets into the whole myth of people with big lungs are better endurance athletes, which is completely false. The lungs are massively overbuilt, and it's a chain. And within that chain, there are limiters, and the lungs are not one of those limiters. So it was funny to me when they're saying that there's too much air around, and there's already more air in your lungs than you would ever need under most conditions. So if someone has a healthy set of lungs and they don't have this insanely high VO2 max or cardiac output at that point, but for the most part, under most conditions, when the hemoglobin comes into the lungs, the blood that comes out is completely saturated. And so that means that the transfer of air and oxygen from the environment to the blood is not a limiter. And so, and if we're going to bring up anecdotes about this, what about that one guy that had lung cancer that managed to win the Tour de France? Who knows how much he actually his lungs healed after that, but he had significant cancer in his lungs. So it's just a weird argument to me that there's too much air in the lungs during mouth breathing. But again,
I think this is when Damien first brought this up in the coaching toolbox, I think, episode. That was, I remember my first point was that you have to sort of think about the end goal, which is getting oxygen to the working muscles in aerobic sport. And what are the limiting factors along the way, and how much oxygen you get into your lungs isn't one of those limiting factors for the majority of people and anyone that doesn't have any issues there.
Mm-hmm. Mm-hmm. Exactly. And to get to that point is, if you think of, physiological processes as kind of chains, and some of these chains have branches. And if you think of taking oxygen from the environment and then moving it down to the cell, if you think of it just even in an engineering system where you're trying to transfer something from one point to another, if it's a linear process like that, it only takes one place to be constricted, and then that slows down the whole process. And in my mind, I think, well, wherever that restriction is happening, there's probably a high likelihood there that that's where the physiological adaptation is going to occur, because that's where the stress is occurring. May or may not be the case in all situations. But for a practical example, okay, when you exercise, especially if you're untrained or coming back from an injury or something like that, one of the first adaptations that happen is an increase in plasma volume. Now, you also get an increase in plasma volume when you are exposed to heat stress over and over again. And you could argue that you are getting exposed to heat stress when you exercise, right? Because you get hotter. But one of those situations, the heat acclimation, you actually get a bigger increase in plasma volume than you do in exercise. And so you could think, you're like, oh, well, if I'm getting a bigger increase in plasma volume from the heat acclimation, and plasma volume is one of those things that helps you improve your performance during exercise, then maybe I need to do heat acclimation to bump my plasma volume up past where I would get during exercise, and therefore I would have a bigger benefit from that bump in plasma volume. Except that really isn't necessarily the case, because there's evidence to show that just simply increasing plasma volume isn't enough to really do a lot in trained cyclists. It's kind of one of these things where the jury is still out. So you can think, these interventions like breath holding, where you are not really training in, say, like a specific way, like high intensity interval training or something like that. If you're doing, especially with a breath holding that's off the bike, per se, right? And even if you're saying like, well, you get this, maybe the splenic adaptation or something else that's similar, even if it bumps it some kind of physiological adaptation past what you might get through the exercise intervention, it doesn't necessarily mean that adaptation is going to be, again, physiologically meaningful when it comes to something that results in a performance increase. All of these things should be taken into consideration. And this is why, for me, it's always good to have a well-designed training intervention with some trained cyclists and to see how the results are after that, so that we can have a decision. And then not only that, you might want to see like 2 or 3 of these things, these interventions studies, and make sure that the results are reproducible. But of course, this gets into that conversation that we've had on here before. People in performance sports are looking for that advantage that other people don't have. They're looking for the edge. They just want that little, like 0.5%, that 1%. And that can easily lead you down this road, because you're going to read some papers and you're going to be like, oh, if I could just do this intervention and get that 25% or 0.25%, I should say, and improvement, then that will really make a difference in my time trialing or something like that. And people will jump on it because early on, you will not have the research that will help you and guide your training. So it is a trade-off for some people at some point, especially the people who are maybe at the very, very high levels, where they're like, they would need to jump on something, or they feel incentivized or pressured to jump on something without the best evidence out there to kind of guide how to do the intervention or to even validate the intervention will improve their performance the way they think it will. So here's my little spiel there.
All right, let's just wrap it up here then.
Yeah.
I did want to just do a passing mention of this other idea of filtering, warming, and humidification of the air, because it's pretty well understood, or at least when I started looking into it, I was like, yes, of course, the nose is a filter, and it also warms and humidifies the air. And this process that happens when you're breathing in the nose it will change the temperature and the humidity of the air. And so potentially then the difference between mouth breathing and nose breathing means that you could be changing the air so that things like dust particles, which are triggers for conditions like asthma, it's sort of helping that. And it's also said filtering as far as like protecting you from illness, from any types of airborne viruses or whatever that you're potentially exposed to. And we start to really move away from like a direct performance benefit here.
Yeah, exactly.
And so it's hard to kind of sell that to me. Maybe under some general health thing, your nose is just designed to do this, and so just breathe through your nose more.
Yep.
Maybe the easiest recommendation here, but I'm having a hard time linking it directly to a performance benefit. And there's nothing that can back that up. No one's actually looked into this that I could find. So yeah, just a general recommendation there, but it doesn't hold any weight really for me. Overall, when I look at this topic and the stuff that I've looked at, and definitely considering in the input from both you guys, I can safely say that currently there is no strong evidence that nasal breathing helps improve athletic performance in healthy subjects. That's my definitive answer to all of this. We touched on this, and there is a lot of areas that breathing you can get into with breathing. And it's not just performance. There's things about arousal states, and there's well-known wisdom that's been passed around for hundreds of years about different breathing techniques. And there's a lot of that stuff being picked up and commercialized in the last few years and things. And there is some merit to part of this, but will I be including it in any of my coaching practice? The answer is a hard no at the moment. Nothing has convinced me to do any of that stuff yet. I do a little bit of breathing techniques myself, but yeah, if I was to roll this out, I just couldn't justify the time and the energy to do it. So that's kind of where I've come to after looking at this. I've enjoyed looking at it because it has opened up so many questions. Again, like this thing of when to introduce things, what level of evidence do you need? How does that information reach you? And perhaps we should do a case study on something like this and break it down bit by bit, why this doesn't work, why we would be skeptical about these certain claims and things. I think that would be really beneficial because it's part of a bigger thing. It's not just one paper or a group of papers or some science that's been done and then that's good enough. You have to sort of look in context and how it's being presented and cherry picking and all of these types of things. And I think that's a really useful skill because there seems to be a lot of these 0.5%ers that are out there selling their wares, and it would be good to have a bit of an understanding on how to navigate this, I think.
Yep.
I came across one argument that somebody had written in kind of a, not quite a journal, but it seemed like a professional article. And they were talking about mouth breathing syndrome, which I guess is something to consider, and all of the kind of detriments with that. And if you are an athlete and you have this syndrome, they were making an argument about how all of the kind of detrimental things that could happen from it and therefore decrease your performance. But I think that gets into a similar argument with what we made around core strength and back pain for athletes, and the analogy of the motor oil in the engine, right? If you have this mouth breathing syndrome, And if it just improves your health, they were talking about how people who have mouth breathing syndrome are more dehydrated because they're more of the moisture from the lungs is escaping. That just comes down to not a performance increase, but reducing a health issue that would help reduce the potential detriments. But I think it was something worth mentioning, and it wasn't, they weren't necessarily selling it during exercise. It's more like when you're not training type of thing, right? So, but otherwise, I agree with you, Damien. I think I would not be pushing any of this onto an athlete right now. But, if it came up again and I started seeing more convincing arguments and research around it, then it would be something to reconsider, because at the end of the day, it's not a real hard thing to prescribe for your athlete. Just take some time to breathe in this way. But again, I'd want to see some pretty extensive research around it before I would dive into it. Cyrus, what are your thoughts?
Yeah, basically echoing what you guys have said and what I said earlier. It is a pretty easy intervention, which would mean that I wouldn't have to see too much evidence before I would include it, but I would have to see some concrete evidence, and it doesn't seem like there's any of that at this point to show that it's going to lead to a performance benefit. And in the end, any intervention that we're implementing, we want to see a performance benefit.
Yep.
So until I see a study that shows that, I don't think I will be including it in my training or the training of any of the athletes I work with.
Yeah, and the other thing is like, as I've said before, athletes aren't robots. They're going to have a buy-in on this as well. And if you have an athlete that's skeptical like we are, they're going to want to see the evidence for it too. They're going to be like, this looks a little bit wonky, right? Because there's plenty of really smart, intelligent, skeptical athletes out there are going to be like, this, I don't know about this. And then you will have to provide the research to convince them that this is good to go. So it's not just us that has to be convinced. I would imagine like we would have to have the good studies to be able to show the skeptical athlete that it would actually work as well. So another kind of hoop to jump through before I'd be prescribing this.
Yeah, I think we will wrap it up there.
Yep.
And thank you, Damien, for doing all of the research on this, and to Jason for all the physiology background behind it and talking people through the science behind nasal breathing. So if you would like to get in touch with us, you can do that on our social media. So on Twitter, that is @CyclingClubPod, and on Instagram, that is @CyclingPerformanceClub. And you can also find us on Facebook by searching Cycling Performance Club. If you're enjoying the podcast and you would like to leave us a review, you can do that wherever you get your podcasts, and that will really help us promote the podcast and share all of the research we're doing with a wider audience. Thanks for listening, and we'll talk to you next time.